Got it.
Okay.
Yes. Okay, is it recorded? Let me see. Stop recording. Yes, I think it's not recorded already.
Yes.
Okay. Okay. So yeah, I think we should start. Right. Basically, okay. So good. So good afternoon all. Right. So for this session, we just need to have a little bit discussion on the lecture slide and the tutorial questions. Right. It's some sort like a Q&A session for you guys. And before that, right, so I need to share a bit. Okay, so I need to talk about. So do you guys have this book with you, soft copy? Can you give any response? Do you have this book?
No, sir, we don't.
Only other version.
Other version, right? So I think other version will do as long as the author are the same. Okay, the authors are the same. Okay, so you if you don't have this book, you can just go to Google and type the name of the book and then the name of one of the author, the first author, and then .pdf. Then you are able to find the soft copy. I think so, right? So I think this book is quite useful because like the questions for especially for chapter 3, right? So I go to chapter 3. I maybe I give you one of the example. Oh, like okay, so let's say question number 5, right? So there is a property of the beam. For example, W360 multiply with 64. This is a property of the beam, right? So basically for this property of the beam, right, you need to refer to the appendix of this book, right? So the appendix of this book, right? Okay, so you just go to appendix C, and then you are able to view the property of the beam, right? So for example, the designation for just okay. So for example, W336 multiplied with 302, right? So we need to get the value for the moment of inertia, right? So we need the value of the moment of inertia because when we trying to calculate the deflection, right? 1 over EI multiply with the equation, isn't it? Right. So the I value, right? So we need to get it from here. If the I value is not given, right? Sometimes the question is given in the property, okay? Format the property of which question like this property of the beam, okay? So I think it's better for you to try to get this book in a soft copy, if it is possible, right? If possible, right? Okay, so okay, so now back to our Q&A session. So we start from chapter 1. Okay, so for chapter 1, do you have any question regarding to chapter 1 concept of stress? Either in for the lecture slide or for the tutorial question. Do you have any questions?
Thank you.
Any question? Why so quiet? Now we have how many person? 35. 35 minus me and Tiong. I think 33. Okay, most of you are here already. Right. So do you have any question regarding to chapter 1, concept of stress? Yeah, you just go through the tutorial. If you find any questions are quite difficult, so you just let me know. I can explain on what is the step that you need to perform in order to calculate the solve the problem. Just let me know. It's too quiet.
It seems all no problem for tutorial
okay.
one.
Really no problem. Oh, I'm so happy all of you have no problem with this chapter. Hopefully I can set some harder question for the online test later on. Okay, so really no questions? Okay, it's okay. So okay, so basically, I just want to emphasize that for the chapter 1, you just need to know the normal stress, shearing stress, and bearing stress. Okay, so all formula very easy, F over A. Just that you need to know how to get the member force and the area, yeah, cross-section area, especially for the shearing stress. Okay, so yeah, okay, still finding my tutorial, really. Okay. So it's okay, take your time, no worries, because we have 1.5 hours. Okay, so just take your time, right? So I will give 5 minutes for you guys to find out what is the question you're going to ask for this chapter 1. Okay, so basically for chapter 1 we have a few questions. So question number 3, do you have any question regarding to question number 3?
Yes, sir. I have a question.
Okay, so please ask.
All right. For question number 3, how do you know which section to take actually? I mean, sometimes we just need to take one section, such as BF.
For question number 3, wait for I need to set up something because my earphone cannot hear. I don't know why.
Yeah.
Hello.
Hi, Hamid. Can you repeat the question again?
Yeah.
All right.
And speak louder because I
All right. I mean, for questions such as question number 3, we need to take AE or BF or DG sometimes, right?
can you can you speak louder because I really can't. Your voice is quite low, so yeah, maybe you can put your mic a little bit closer to your mouth and.
All right. Let me set up the mic 1 second.
Huh? Okay, done.
Hello, can you ask the question again?
Hello. Is it better?
Yeah, it's better now.
All
Correct.
right.
Okay.
For questions such as number 3,
Yes.
how do we know actually which section to take actually? Is it AE or BF? Because sometimes we don't need other sections, right?
Yeah. Okay. So for this question number 3, right? Basically, actually for chapter 1. Okay. So for the question, basically we consider method of we are using method of member. We're considering the force acting on the member, right? Okay. So for this case, right? So since that we have a loading, okay, apply load at point C, right? Basically, we can use the ABC, the link, ABC link, right, to calculate the force for AE and force for BF. Okay, so for example, if you have, okay, so now we have a link here. So let's see, okay. So since that we know the, okay, so we have a force here, right, isn't it? Okay, so 800. Okay, so insert. Okay, so here is 800 Newton, right? So at point C. Okay, so at point C. Okay, so here, right? Okay, so after that, okay, so from we are able to use this ABC. ABC, yep. The link ABC. Okay, ABC. Okay, so we are able to use the link ABC to calculate the force. Okay, so the force at point B. Okay, so like this. Okay, so you can assume the direction of the force FAE. Okay, and BF. Okay, so up to you. Right, so sorry. So okay, so FAE. Okay, so FAE. Okay. Okay, so FAE and this one will be BF. Okay, so force for, okay. So just apply the equilibrium equations, sum of the moment. For example, if you want to determine the force for BF, you just assume that sum of the moment at A equals to 0. And then after that, you apply sum of Fy equals to 0. Okay, so it's basically is these two equations. Okay. Okay, copy. Okay, so all you need to do is just apply this two equation. Okay, so to determine the force for AE and force for BF. Is it okay?
Yes, understood.
Yeah. Okay, so because this one involved with the angle, so you need to know the angle. Okay, so this one, wait a minute. Okay, so okay, so this one is 3. Okay, so the angle is 3. For okay, so as so from this section, right? So we know that 300 meter, 400 meter, and then the angle is if you're using trigonometry, so 3, 4, 5, right? So from there we are able to use the angle. Okay, so know the angle for FAE and FBD. So basically, if you are using the link ABC, we only able to determine the force for member AE. Okay, so the force for member ABE. So in this case, how do you calculate the force for member DG? Do anyone face any difficulty to calculate the force for member DG? Anyone? Okay, so basically you can just turn on your mic and then respond respond me. Okay, give me a response. So it's quite easier because I cannot switch between the presentation slide and the chat area. Okay, so you just Okay, so let me know if you have any difficulty. Okay, so to determine the force for member DG. Okay, so from here, so then I think I just explained on how to determine the member for DG. Okay, so in this case, so let's look at this diagram. So I try to use this diagram. Okay, and then I draw the guideline. Okay, so I turn it to red color and then thicker a bit. Okay, like this. Okay, so basically we have these three parallel, isn't it? Okay, so parallel. Okay, parallel, right? Okay, so and then I draw one horizontal line. Okay. Horizontal line. Okay, same. Okay, like this. Yeah. Okay. So now if we look at this diagram, so are you able to see the diagram?
Yes, we are
It's-
able to see the diagram.
Okay, is it clear? Clear, right? Okay, so shouldn't be a problem. Okay, so let me. Okay, so using the weight. Okay, so now. Okay, so now. Okay, so I need to draw the. It's very hard for me to draw because I don't have a stylus pen. So yeah, just need to give me some time. Okay, for the drawing. Okay. Maybe I zoom a little bit bigger. Okay. Okay. So now, okay, so for the angle I draw, okay, so I use as name it as let's say insert symbol. Any symbol I'm going to theta. Okay, good. Home. Maybe small a bit. Okay. Okay, let's say okay. Okay, so for this okay, so wait. Okay, so now, right. So if you look at here, right, this is the angle. We name as angle theta, right? Okay, so theta. We know that these three lines are parallel, right? Okay, so if this is theta, how about? Okay, so we will get. Okay, so for this one, also theta, right? Angle theta. Okay, this one as well theta, right? Okay, so if this one theta, right? So this is for the horizontal line here. So how about this angle? The angle at that point. Any response? No response? Okay.
Same.
Same, right? So okay, so now we have a same theta, right? Okay. So okay, so for this length, okay, so the length I show you, I showed down. Okay, for this length, okay, what is okay? So what is this? The value for this horizontal length? This horizontal.
200?
Yes, 200, right? Okay, so if we know that this is 200 and we have this angle, okay, so right. Okay, I will think a bit. So are we able to determine the length of the blue line that I draw?
Yes.
Yes, right.
Yes.
So the blue line and the force dg, right, is perpendicular, isn't it? Is it okay?
Okay.
Yeah, yeah. Right. So okay, so x, let's say x. Okay, so okay, so let's say the length of the blue line is x. Okay, so okay, so from that, if we're using sum of the moment equals sum of the moment at f equals to 0. Okay, so f, okay, so f dg, okay, f dg. Okay, okay, so f dg multiply with the x value. Okay, so it will be one of the moment component, okay, for the sum of the moment at f equals to 0. Is it clear?
Yes.
Okay.
Yes.
Okay, so and then we have the AE, right? For the AE section. So for the AE section, you just need to uh, get the vertical force for the FAE and then multiply with 150 mm. Okay, so then you will have another component of the moment. Okay, for the sum of moment at f equals 0. Okay, so by comparing these two moment, okay, you are able to determine the force at for the DG member. Okay, so as simple as that. As long as you know the x value. Okay, for this question number B. Okay, it wasn't that hard as you thought, but it's quite tricky because they deal with a lot. Okay, so deal with this angle. Is it okay? So is it clear, or are you still doubt?
So far, it's clear. Yeah.
Okay. So okay. So this is about yes. Questions?
Yeah. Can you hear me?
Yes. Yes. Yes.
Yes. Just to add on, for your question just now, Hamid, that you asked why do we take ABC and why do we take this part here? I think the first thing that we look at is that if the question says that we want the stress at member AE, right? It has to be a member. You have to take a member that has A in it, right? Okay, it has to have A in it. Maybe I share the screen with you.
Okay.
Can you see my screen? Yeah, this is the solution, right? Can you see my screen?
It's still loading. Still
Wait,
Oh, still loading. Okay.
yes, we can see it.
okay. So proceed.
Okay. Right. Yeah. So you see your question just now was which member do we take? Okay. So if it was the question requires us to find the forces or the stresses at AE. Okay. So which means that we have to take something that that will involve A and E, right? It has to involve A and E. So we search for the easiest one. Okay, there could be other possibilities. We could take, for example, the whole diagram. But if you look at part A or part A, this would be the easiest one. Okay, this would be the easiest one. It has to have A in it because it's connected to this one. And for part B, to find DG, it has to have you have to take a member that has either D or G. So which means that this would be the easiest member to take. So does that make sense to you?
Yes, it makes it clear.
Yes. Yeah. Okay. All right. Back to Charlie. Thank you.
Okay. So right. So hopefully, Mr. Teng is able to clear your doubts. Right. So any questions regarding to the this is about normal stress, right? Okay. So normal stress. Okay. So how about the shearing stress? Do you have any difficulty for the shearing stress? Okay. So for question number 5, is it okay? Any doubts?
Yes.
Yes, sir.
Yes. You mean you have doubt?
Yes, sir. Okay, so sir, how can we differentiate the steel rod and the aluminum? If you look into the answer, it's pretty confusing because he's taking that a diameter for steel rod different and aluminum different. Can you please explain this?
Oh, okay. So okay. So maybe I think I need to draw. Okay. So now, right. Okay. So back to. Okay. So for this one, right. So we know that. Okay. So the top. Okay. So this one is a steel, right? Okay. So let me. Okay. So this is the steel. Okay, and then this is the aluminum plate. Okay, so okay, so aluminum, right? Okay, so now, okay, so insert equation. Okay, so shear. So we talk about shear, right? Okay, shear. So equal, pretty easy. Okay, so F over A. Okay, so if you want to determine the shear for example, the first one. Okay, so if I want to determine the shear for the aluminium. Okay, so if I want to determine, okay, so the shearing stress for the aluminium. Okay, so the A that you taken, okay, so the A taken mass from aluminium. Okay, mass from aluminium. Okay, so how do we take the area? Okay, how do we take the area? So first, right, so as mentioned in the lecture, right, so for example, if we have okay, so I need to draw a 3D. Okay, so maybe I draw, okay, so let's say, okay, so if I have this and I try to make it okay, so like this better. Okay, so larger a bit. Okay, so now, right, so for stress is depend on the force directions, right, that you apply on the area. Is it okay? So for example, if we have a force in these directions, right, the stress that we calculate is what stress? Normal stress or shearing stress?
Normal stress.
Okay, so normal stress, right? So how about shearing stress? So we know that, okay, for normal stress, the area must perpendicular to the
Normal
force that,
stress.
okay. So for the shearing stress, okay, so shearing stress, okay, so it must, okay, so for the shearing stress, okay, it must be some sort like, okay, so like, okay, so if the force is in these directions, okay, so force in, for example, in this direction or the other side, right? So let's see. Okay, so in this direction, let's say. Okay, so along the surface. Okay, along the surface. So the stress that we calculate is a shearing stress. So now you have an idea. So where is the direction of the area that you need to consider? Okay. Okay, so back to question. So what is the direction of the force that apply, okay, on this structure? Okay, so the force that apply, okay, so the force apply is in this direction, isn't it?
Yes.
Okay, so force apply in this direction. So therefore, the area that you need to consider is a vertical, okay, a vertical area, isn't it? Right. So for vertical area, and then, okay, so for example, now we need to calculate the shearing stress for the aluminium, right? So the area must be somewhere here. Okay, somewhere here, right? So if we okay, so therefore, if we apply, okay, so what happen if you apply the force, okay, from here? So basically, it will subjected around. Okay, so here, from here to here, right? Transmit. Okay, so you can imagine, just imagine the steel rod, okay, punch through the aluminum plate. What will happen to the aluminum plate?
Break.
Okay, okay, so if the steel rod punch through the aluminum plate, okay,
Aluminum break.
okay, so not break. Okay, so the hole will become bigger, isn't it? Punch through, right? So this basically, okay, so let me show you this section. Oops. Okay, so this section, these two section, right? Okay, so larger a bit the screen. So basically, these two section will be gone, right?
Yes.
Because
Yes.
the steel punch through the aluminum plate. Okay, so the hole is getting bigger or larger, right? Okay, so where is the contact area in the same as the direction of the force from the aluminum?
It's the one marked red, isn't it?
Is this one, right?
Yes.
Because this one is fall out, right? So basically is the circumference. Okay, so like this, right? Okay, so the circumference, right? Okay. Okay, so the circumference multiply with the thickness of the aluminium. Okay, so the area must come from the aluminium. Okay, so the area must come from the aluminium. Okay, so therefore the A for the A for the aluminium, so will become, okay, so will become pi. Okay, so pi multiply with D. D is 1.6 because the hole is getting larger, isn't it? After it punched through 1.6, then multiply with the thickness of the aluminum plate, 2.5. Okay, because this one is gone, right? Okay, so just imagine it's punched through, and then this is the contact area. Okay, because this one is just a cross section. So if in 3D, so basically it's around the circumference, the area. Okay, at the inner radius. Okay, so it's very hard for me. Okay, so maybe I draw in. Give me a second, so I can show you a bit better picture. Okay, so okay, so no, subtract. Okay, so okay. Shit. Formation. Okay. Right. Format. Okay. Okay. Okay, so now, right. Okay, so the area that I mentioned is this. Okay, around. Maybe I should lower down a bit. 10. Okay, so what I mentioned here, right? So the thickness is 2.5, right? So after the steel plate, steel rod punched through the aluminum plate. So this is the blue color is aluminum plate. So it's punched through. So the whole size become larger with diameter. So basically the diameter here will be okay. So this diameter, okay, from here is 1.5. Okay, so the diameter will be 1.5. 1.6. Sorry, it's not 1.5. So diameter will be 1.6. Oops. Okay. Okay, so this diameter will be 1.6. Okay, so thickness same 0.25. Okay, so pi d is the circumference multiply with the height, the thickness of the aluminum plate. So it will give you the area, the contact area for the shearing stress in the aluminum. Is it okay?
Yes.
Okay, so same thing. So if you want to determine the shear stress in the steel rod, right? You just assume that the aluminum plate cut through the steel plate. Okay, cut through the steel plate. Okay, so if cut through the steel plate, okay, so imagine that. Okay, same thing. Okay, so if I put the direction up, okay, so now the direction will be starting from this point, going up. Okay, at the edge, basically at the edge, right? So, okay, so this point from here going up. Okay, so if cut through, which means this section is gone. Okay, no more. Okay, so for this section will be gone. Okay. Okay, so this section will be gone, no more. Right, so it's some sort like trimming. Okay, so trimming progress. Okay, so process. So for this one, so if you trim, right, so if you look at here, it will be the hole size. So this 1.6 will become 0.6. Okay, so from here, this one will become 0.6. Okay, the length, the diameter. Okay, so will become 0.6 after it cut through. So the A area for the steel will be pi multiplied with 0.6 multiplied with 0.4, because the area must come from the steel when you want to calculate the shearing stress for the steel. Okay, so this is how I think it's the easiest way to determine the area, okay, for the shearing stress. Okay, so the force, okay, still, okay. So questions so far? Any questions regarding to the shearing stress? Any question? No?
So why in the solution he said it's pi times 0.6 times 0.4, not 0.2?
Yeah, 0.6 times 0.4, because you want to calculate the area for the steel, isn't it?
Oh, all right, I see.
Okay, the area must come from the steel. So you need to take the thickness and then multiply with 0.6, right? After it trim up. Okay. So this is how we determine the shearing stress. You need to look at the directions of the force. Okay, when you want to calculate when you want to consider the area, okay, to calculate the shearing stress.
So for steel it's 0.6 since it's only for the steel part. So the aluminium is including the pushing down part, the area which are removed.
Yeah, here.
All right.
No, here, right, isn't it?
Yeah.
So 1.6, and then because we want to calculate the area inside, okay, surrounding
getting
the
past.
surrounding the circumference, because this area have a contact with the force, right, in the shear. Okay, so that because the force, if you can see the force, okay, so basically the force is surrounding. Okay, so give me some time. Okay, so the force direction is something like this, right? Okay, around this. Here. So can you see the direction of the forces?
Yes.
Yes, right. So if the direction of the forces is in this direction, so the area that we taken will be the inner, right? Inner surface, right? Isn't it? Right? Okay, so shear and area. Shear and area. Okay? So
Alright,
just you all you need to do, you need to identify the direction of the force. Okay, so if you want to calculate the shear stress, the area taken must be along the force, right? Okay, so not perpendicular. Perpendicular is to calculate the shear the normal stress, not the shearing stress. Okay. Okay, so about the shear stress. So bearing stress is quite straightforward. So I think I just leave it to you guys. Is it okay? For the
Yes.
sharing stress, no question, right? Okay, so if no question, I need to jump to the next chapter. Okay, so for the design of beam, I don't not really emphasize on that one because this is just a recall from what you have learned in MOS. Okay, so MOS. So for structural mechanics, so the most important part is to use, okay, so to get the moment from the beam, okay, so what you have learned in chapter 2, and then apply it to determine the deflection of the beam. Okay, so far any question regarding to the deflection of the beam?
No.
It's quite quiet, guys.
I mean, we are only two talking, so.
yeah, it's good. Only two because you have a lot of students here, right? I think it is around 37. One has left, and then yeah, so you just please to join the our discussion, or else it will be no meaning, right? Okay, so how do I going to clear your doubts if you didn't ask any questions?
So do we need to do for 6, 7, 8? So
6,
just now you
7.
said,
What 6, 7, 8?
uh,
Yes, this question. Yes,
you said,
it's
no.
relevant.
Oh, okay.
Yeah, it's relevant. So question number 8 basically is linked to question number 1. Okay. Yeah, you just need to refer to question number 1 to calculate the question number 8. Right. So answer is there. So you just need to try. I'm not encouraged for you guys to study from by reading the solution. It's not used at all. Okay. So until the end, you figure out that it won't help. Okay. So back to our discussion, right? So for a deflection of the beam, so basically we have two methods, right? Bisection or singularity function, right? Okay,
Yeah.
so I think I left out something during the lecture. My last lecture is the because I want to talk about this because there are some questions regarding to this. Okay, so regarding to this. Okay, so statically determinate beam and statically indeterminate beam. Okay, so do you recall these two? Okay, so I think on the last lesson, right? So I actually I planned to talk about this, but eventually, yeah, we are in MCO now, right? Okay, so for this one, I just need to just go through a little bit, right? Because for the tutorial question starting from let me see, starting from starting from question number 8 and onwards, it's considered. The question is considered as a statically indeterminate beam questions. Okay, so question 8 and onwards. Okay, question number 8 and onwards. Right. Okay, so for statically determinate beam and statically indeterminate beam. Okay, so they are actually it's very easy to identify. Right. So for statically determinate beam, the reaction at the support can be determined from the equilibrium equation directly. Okay, which means at the beginning, so if you apply sum of moment equals 0 and then sum of Fy equals 0, so you are able to determine the reaction at support. Okay, however, for statically indeterminate beam, the reactions at the support cannot be determined from the equilibrium equation directly. Which means if you apply sum of moment equals 0 and sum of Fy equals 0, you won't be able to determine all the reaction. Why? Because the thing is, if you look at the diagram on the left side, right? So for this one, it's simply support beam, right? So for the reactions, we only have AY and BY. Okay, for AX, normally for deflection for the beam questions, so we just ignore the reaction on the x-axis because x-axis it will always become 0 lah. The reaction at the support on the x-axis, right? So for this case, we only have FAY and BY, right? So if we apply sum of moment equals 0 and then sum of Fy equals 0, so we are able to determine the AY and BY directly, isn't it? Right. Sorry. However, for the question, the right diagram here, right? Okay, so if you look at this diagram, so how many reaction do we have here? Anyone going
5.
to? Huh? 5.
5.
Is it 5 without the P?
We not no reaction. The reaction as support.
4.
Ignore the horizontal one.
3.
Ignore the horizontal reactions. AX, ignore the AX. How many reactions?
4, isn't it?
3.
At
3,
at
right?
at at point A, how many reactions do we have here?
2.
2.
AY and
MA.
Moment.
MA, right? AY and MA. Okay, so fixed support, right? AY and MA. And then at point B, we have
What?
BY, right?
B1.
So in total, we have 3 unknown, isn't it?
Yes.
Yes.
3 reaction need to determine. So if we applying the equilibrium equations, sum of moment equals to 0 and sum of Fy equals to 0, are we able to determine all the reactions?
No.
At some point? No, because the number of unknown is more than the number of equation that we can derive, isn't it?
Yes.
Okay, so for this case, right, some of the student, they might think of, why don't I, okay, for the first equation, I use sum of MA equals 0. For the second equation, I use sum of MB equals 0. And then after that, I use sum of Fi equals to 0. So in this case, I will have a 3 equation. After that, okay, so if I using this method, will I able to determine all the support, all the reaction as support?
No.
No, right? Okay, so one more thing that you need to memorize, that the sum of moment, okay, if you want to calculate the reaction on the beam, the sum of moment, you only able to apply once. Okay, don't try to use different point, okay, to generate the equation. It won't give you the answer. Okay, so for example, if you want to use sum of moment at A equals 0, just use sum of moment at A equals 0. No need to repeat the moment equation. Sum of moment equation equals at B equals to 0. Okay, so that is not okay. So it's not the right way to answer the question, right? Okay, so please to keep in mind that just use sum of moment equals 0 and sum of Fy equals 0 once, right? To determine all. Okay, so to generate the equation. Okay, so if you unable to determine the reactions directly, okay, so this beam is considered as a statically indeterminate beam. Is it okay?
Okay.
Okay, so
Okay.
how, okay, so from question, how do we identify? So for example, if you forgot, okay, so if you forget already, so how the number of the reaction is more than the equation that I have to derive. Basically, if you look at the questions, right, the pattern of the questions. For example, if you look at the questions, right, when they ask, okay, for the statically indeterminate beam, the question will ask you to determine the reaction first. Okay, for all the support. So if you go through all the question, right, okay, so for example, okay, so for example, for this, it will directly determine the deflection or determine the slope. But for the, if we are using, if the question is on the statically indeterminate beam, so the question asks you to determine the reaction, right? Okay, so as you can see here, for example, question number 8, right? So that's the difference. Okay, so for statically determinate beam or statically indeterminate beam, so no need to worry about that, because, okay, so for statically indeterminate beam, even though you're unable to determine the reaction at the beginning, okay, you just need to proceed, okay, the calculation. But when you, after you substitute the boundary conditions into the equation, so you will have enough equation to solve the reaction. Okay, so you, until the end, you're still able to calculate the reaction. Okay, so yep. Okay, so this is about these two questions. Okay, so statically determinate beam and statically indeterminate beam. Okay, so and you just need to try the tutorial questions. Okay, so basically it will help you out. Okay, so to clear your doubts. Okay, on these two type of beam. Okay, it's not much different. Okay, so just that for statically indeterminate beam, you only able to calculate the reactions at the end. Okay, after you derive the equation of the elastic curve. Questions?
Sir, I want to ask for the condition. Can you explain again how we get the condition?
Boundary condition. Okay, so let's. Okay, so maybe I give one of the example. Okay, so I use question number 6 because question number 6 is more than 4. I think need 4 boundary conditions to solve the questions. Okay, so if you have question number 6, so you can refer to question number 6 tutorial. Okay, so now, right. So for boundary condition, okay, so how do we determine the boundary condition? So boundary condition, right? Okay, so boundary condition. Okay, so first, okay, so from the support. Okay, so we are able to determine from the support. Okay, so support we have 2 types, right? Okay, so simply support, pin support, and or roller support. Okay, so pin support or roller support. Okay, so consider as 1, and then second is a fixed support. Are you guys okay with these 2 support?
Yes.
Okay.
Okay, so pin support and roller support, right? Okay, so for the roller support, okay, y equals to 0, which means if there's the support, okay, the support is a roller support or pin support at that particular point, okay, the y equals to 0. For the fixed support, right, y equals to 0. Oops. Y equals 0, and the dy over dx, which is the slope, equals to 0. Okay, 2, right? Okay, so basically from here, so we need to locate the. Okay, so look at the locations. So for this question number 6, so we have 2 support, right? One is the pin support at point A. The other one is the roller support at point B, right? Is it?
Yes.
Okay. Okay, so x. Okay, so we always start at x, right? X is considered a distance from the origin. Okay, x. Okay, so x is the distance from origin, right? Okay, so for this case, if we consider okay, so if we consider A, pin A, we have a support at A, right? So for A, boundary condition will be x equals to
0.
0.
Y equals
Okay,
0.
so y equals 0 because it's a pin or roller support, right? Y equals to 0 here, right? So y equals to 0. Okay, so for this case, we have, okay, so the other one is at point B. Okay, so point B, x is the distance from origin, right? Point B, x equals to 3, y equals to 0.
0.
Okay, so now we have 2 boundary conditions, isn't it? These 2 boundary conditions is at the support, right? Okay. So okay, so now, so if we by okay, so the quite obvious one is from the support, right? So you can determine the boundary condition directly from the support. So for this case, if you look at this diagram, right? If you look at this diagram, how many sections we need to cut?
2.
2, right? So AC and
B.
BB.
and
BC.
BC. Okay, 2 section, right? So if you cut, okay, so back here. So if you cut 2 section, okay, let me see empty face. Okay, so if you cut, two section. Right. How many constant do we have here?
C1 and C2, right?
Two.
C-
One. If you cut one section, you
two.
we will have two constant, right?
Yes.
Because if we perform double integration, right, you will get two constant, isn't it? C1 and C2, right?
Yes.
Okay.
Yes.
So if you cut two section,
Four.
four constant, right?
Yes.
That we need to determine, right? So if we have four constant, which means we need how many boundary conditions? Four boundary conditions.
Yeah.
Right. So therefore, right. So for this one, we need four boundary conditions. Okay. So now back to the question, right? So from the support, we only able to generate two boundary conditions, isn't it?
Yes.
So how do we get another two boundary conditions? So that's the question, right? Okay. So now if so back to so from so question so the boundary condition. Okay, so second, so boundary condition can be determined at the so at oops, common point. Okay, so what I mean here, so where is the common point?
Point C.
Huh? Point C, right?
Yes.
So why point C?
Because two sections, AC and CP, isn't it?
Yeah, yes, correct. Point C. Okay, so from here, from this case, for this case is point C, right? So because the easiest way, we need to cut two sections, right? AC and BC. So C appear twice, so C. Okay. Okay, common point, right? Okay, so if you look at here, right? So okay, the bottom diagram. Are you able to see the bottom diagram here? Okay. Is it okay?
Yes, can see
Yeah.
it, yeah.
Right.
Yes.
Okay. So for the border diagram, so from here, maybe I change. I cannot change it. Right. So assume that this one, right? ABC. Okay. Right. So if you let's say, okay, so ABC, right? So if we cut, consider two section, right? AB and BC. Okay. AB and BC. Okay. So when we want to calculate the deflection at point B, YB, right? If we are using section AB to calculate the deflection at YB and using the section BC to calculate the deflection at B, okay? So is it the same value? You'll get the same value. If you look at this diagram.
Yes, it's going to be the same value.
Because we only have 1 point, right? B, we only have 1. We don't have 2B, isn't it?
Yes.
No matter you use section AB or section BC to calculate the deflection at B, you will get the same deflection, right? Because it's we only have one beam. We only have a 1 point B. Okay, so we don't have a B. We don't have different value for the deflection at point B. Okay, so therefore, so from this diagram, so we can conclude. Okay, so back to this question. So at point C, okay, so at point C, the locations from the origin will be 1, right? Okay.
Yes.
When x equals to 1, y for AB
Y equals to YBC.
equals to y for
BC.
BC. Okay, so this will be the one boundary conditions at the common point. Okay, so and after that, when x equals to 1, right? Okay, so same thing. The slope dy slope. I use the slope value. Where is insert symbol? The slope. Okay, yeah. Okay, so the slope for AB. Okay, so AB equals to the slope for BC as well. Same, because we only have one point. So therefore, at that particular point, the slope, we only have one slope at point B, right? So same thing, right? So the slope at AB equals to the slope at BC. Okay, so from here, we are able to generate another boundary conditions. So in total, we will have 4 boundary conditions, right? Okay, so 4 constant, 4 boundary conditions. So okay, so by using these boundary conditions, we are able to determine all the constant. Is it clear? So this is
By
about the
theta, you mean dy dx, isn't it?
pardon?
By theta you mean
Theta,
dy
yeah,
dx.
theta is dy dx,
Oh,
slope.
alright.
dy dx is slope. Okay, so basically, okay, so okay, theta. Okay, so some we can write as in theta or dy over dx. Oops, y over dx. So basically, these two are the slope, right? Okay, the slope value, okay, is slope. Okay, so yeah. Okay, so is it clear regarding to the boundary condition?
Yes.
I need to get back to the chat room, see whether there's anyone.
It's okay. Mr. Tiong is taking care of the chat actually.
Okay. So because now we have 38 students, I believe most of you are using laptop, isn't it? So
Yeah.
so it's impossible. So please do join the discussion, right? So I'm trying to help, but you need to ask questions so that I can respond you, or else it's very hard for me to respond, right? Okay, so now, okay, so back to the common point, right? So there are students asking me one questions, right?
Two.
The third boundary condition, the third. Okay, so not this one. Okay, at maximum deflection point. Okay, so for some question, okay, so for some question, for example, for the questions, symmetrical beam questions, so which has, for example, maybe I give you one example pretty fast, right? So from here, okay, so I just roughly draw, okay, so center at the center point, right? Okay, so at the center point, and we have simply support, okay, at both end. Oops, too big. Okay. Okay, so let's say, okay, so text box, okay, so L over 2. And this side also L over 2. Okay, so now, right, so for certain question, right, for example, for this question on the left side, okay, so it's a symmetrical beam, right? So there is a concentrated lot located at the center of the beam, okay? So for this question, right, so do you know the maximum deflection point?
No, but assumably it's gonna be in the middle, isn't it?
Okay, yeah, because it's a symmetrical beam, right? Okay, so left equal to right, and then the loading is at the center. Okay, so for this question, right, so we know that the maximum deflection deflection is at the middle, right? Okay, so it's the middle of the beam, okay, of the beam. Oops. Yeah. Okay, so we know that the maximum deflection is at the middle of the beam, right? So therefore, we can for the maximum deflection, for the point maximum deflection, so dy over dx is equals to 0. Okay, so therefore, from by using this maximum point, we are able to generate one boundary conditions. So when x equals to L over 2, for this case only, right? Okay, for this case, and not this one. Okay, not about this question, right? So when x equals to L over 2, so dy over dx equals to 0. Okay, yeah, like this. Okay, so yeah, this deflection point, maximum deflection point, only can be applied if you know that particular point will have a maximum deflection. Okay, it's not all the question will have a maximum deflection at the center. Okay, it's only applied for the symmetrical beam. For example, for this question, yes. Okay, so like for this question, right? So if you look at, if you cut half at the middle, left equal to right, right? Okay, so for this case, so we know that the maximum deflection is at point C. Is it okay?
Yes.
Yeah, right. Okay, so for example, for this question, let's say for this one. Okay, for this question, right? So we are unable to know that the maximum deflection at which point. Okay, so you cannot apply that when x equals to L divided by 2 or something, right? The dy dx equals to 0. Okay, it's depend on the question. Okay, so this one is depend. Question. So you cannot just simply apply the this boundary condition, okay, for all of the question. Is it clear? Okay, so for this chapter, the bisection method is a little bit difficult compared to singularity function method, as we know that, because the hardest part basically is from the boundary condition. Okay, so how do we determine the boundary condition to determine the constant value? Okay, so just that you need to keep in mind that if we cut 2 sections, we will have 4 constant and 4 boundary conditions need to solve the 4 constant. That's it. Okay, so boundary condition. So if the support is insufficient, so then you need to consider the common point. Okay, the common point. Okay, so if the boundary condition at the support is insufficient for you to determine the constant, so you will need to consider the common point. Okay, so and the maximum deflection is dependent. So if you look at the question, you know that is a symmetrical beam, so you can get the this boundary condition directly. Okay, so you just refer to the beam. Is it clear? Questions, doubts?
So for the example you gave for the maximum deflection point, even if it is one roller, one pin, it's still maximum deflection is in the middle.
Right? Yes, correct. Because AY and BY, right? Even though it's roller, okay, roller means that is free to move on the X directions. Right. But however, Y is fixed. Y is spin, not fixed. Sorry, Y is spin. Okay.
And so for the how we get the value for the I and E, is it given?
I and E is the property of the beam. Basically, for this chapter, we are the most common one. We're using a steel. Steel is 200 GPa. So if the question doesn't give the value for E and I, you just leave it the answer in E and I, in terms of E and I.
Okay.
So for example, this question 6, right? So E is given, right?
Yes.
And then if you look at there, so W 150 times 18. Okay, so for this one is the property of the beam, as I said, right? So maybe later on I will upload the property of the beam. There is a lot of tables, so I can show you. Where is the table I have here? Okay, now wait for a while. Basically, for the table we have, okay. Yeah, here, this one. Are you able to see this? Right, so basically this is the book. Okay, so front cover. Okay, so this is a book, right, that you can refer. So yeah, there's cover all of chapter here, all the chapter. Okay, so all the lecture notes are actually from here. Okay, so for example, if you look at the deflection of the beam, okay, so there's a lot of explanation. Oh, okay, so actually the like lecture note is from here, right? So if you have this book, Okay, it's quite good for you to refer, right? And there's a lot of question as well for you to try out. And okay, so now, okay, so basically for the property of beam we are referring, okay, so just go to appendix and then go to section C. Okay, so from here we have a lot of, okay, so this, right? So there's a beam here, okay, the property of the beam. So from the I value, you need to refer from here. Okay, so for example, the delineation. So you just look at the chord, okay, from the questions. Okay, so you just identify the chord here, and then refer to this value. Okay, so the x-axis. Okay, okay, so the x-axis here. Okay, okay, so just refer to this x-axis and then ix. Okay, so for example, okay, so if you look at here, W 920 multiplied with 449, right? So the I value, okay, I value that you taken, just refer to the x axis, right? So ix value, this one, right? At 780 times 10 power of 6 millimeter. The unit is in millimeter power of 4. So you need to convert to the meter power of 4, which means you need to multiply this value with times 10 power of negative 12. 12 because it's power 4, right? Okay, so yeah, you need to, okay, so this one is S7 S0 times 10 power 6. So if you multiply, if you convert to meter power 4, will be S7 S0 times 10 power of negative 6. That's it. Okay, just put a negative sign there. Okay. Okay, so this is how we get the table. So I think later on I will upload this property of the beam, easy for you to solve the questions. Okay, for the deflection chapter.
Okay.
Okay, so
He's asking you, I think, in the chat, do we always get the I value in the x-axis direction?
yes, for the beam, yes. For the deflection of the beam, yes. Okay. Any questions regarding to
So-
this property of the beam?
You need to the value of I need to in mm square or mm.
Huh?
The unit of the I.
I is either I is meter power 4. The moment of inertia units is meter power 4. But in this chart is given millimeter power 4. You need to convert to meter power 4.
Okay.
Okay, so for this value, right? So S7 S0, so will be time 10 power of 6.
Okay.
Okay, millimeter power 4. So you need to convert it into a meter power 4. Okay, so this is the I value. Basically, will be given.
Okay.
Okay, so I back to the slide. Go back to the slide. Okay, so now, okay, so any question regarding to boundary conditions? Yeah, how to determine boundary conditions? Just let me know.
Sir, I have a question.
Yes, ask.
Let's say for question 7, if you are asked to find A, B, C, D to E, then can I say that we have two common point?
Uh,
Two common point are B and D.
So for this question, right? If you read the question properly, the question asks you to derive the equation of the elastic curve for portion. For portion, which portion?
A, B, C.
Question number 7, isn't it? You mentioned
Yeah.
about. Okay, so if you so back so you read the question.
Or BD.
Okay, so the question asks you to determine the equation of elastic curve for BD, right? Okay, BD.
Yeah.
So you need to cut this section, isn't it?
Yeah.
Okay, so if you cut one section, right? So did you realize that there will be no boundary conditions between BD? Because no support in between BD, isn't it?
Yes.
Okay, so no matter how, you need to cut another section, two section, right? Okay, so now for this case, we will need to cut section AB and BD, two section, right? We need to consider two section.
Yes.
Okay, so for AD and BD, so now we talk about because we cut two section, we need 4 boundary condition, right? The hardest part, right? So I copy this one first. Okay, so back to here. Okay, so boundary condition, as said, the first thing is at the support, right? Okay, so pin support, and then okay, so from here, okay, so at point A we have one boundary condition, isn't it? X equals to 0, y equals 0, right? And at point E, so this was at point E, when when x equals to L, y equals to 0. Okay, so now back to, okay, so I split it up, section AB. Okay, so section AB basically is from 0 x to L over 2, right? Okay. Oops. Okay, so section BD. Section BD will be from A equals to L minus A. Okay, like this. Okay, so L minus A. So section BD. Okay, so two section, right? So if you look at the boundary conditions that we obtain from the support, A is belong to which section? If you want to substitute into the equations,
AB.
okay, A is for AB. Okay, A is valid, only valid for AB. Okay, you cannot substitute A to section AB and A to section BD. Okay, so because x equals to 0, y equals 0 is only valid for AB, because if you just look at the range here, okay, x from 0 to L over 2. Okay, so here is x0, right? So this boundary condition only valid for section AB. Is it clear? Okay, so next is a point E. So for point E, we will have x equals to L, y equals 0. So for these boundary conditions, okay, can we apply for section AB or section BD?
Cannot.
Cannot. Or can?
Cannot.
Cannot. Why?
Because it's outside of the range.
It's out of the range.
Yeah, it's outside of the range. So therefore, you don't simply substitute the boundary condition into any equation. Okay, you will get a wrong answer. So you need to ensure that the boundary condition is valid for that particular section. Okay. Okay, so this is from the support. Okay, so for this case, this one is okay, so it's invalid. Okay, so not valid. Okay, so not valid. So out. Okay, so cannot be applied anymore, right? Out. Okay, so now we only have one boundary conditions at point A. So one boundary conditions. So if we cut two sections, as I mentioned here, two section, 4 boundary condition, right? So now we only have one boundary conditions. So in this case, we need to consider the common point, right? The common point. Okay. So when x, okay, so common point is at point
B.
If you look at here, section AB, BC, B appear twice, so B, right? Okay, so the easiest way, right? Okay, so if you look at the point B when x equals to A, okay, when x equals to A, right? So AB equals to BD, okay, BD. Okay, so and then theta BD. Okay, so from this common point, we will generate 2 boundary condition. Okay, so 2 boundary conditions for these questions, right? So in total, how many boundary conditions do we have here? Not 4, because this one is out already, right? Okay, the boundary condition at point E cannot be applied. Okay, so because it's not in the range, right? So the boundary conditions is the valid boundary condition is what we have here is 3, right, in total, right? So 3 in total. Are we okay? So 3 in total. So how? And then this one, right? The last one, okay. Basically, is these 3 lah, okay. Max deflection point, right? Depend on the max deflection at the middle of the beam, right? So when x equals L over 2, dy dx equals to 0. Okay. So in total, 1. Okay, so 1. Highlight it. 1, 2, 3, and 4. Okay. So by using this 4 boundary condition, right? So we are able to determine the constant one we perform the double integration for section AB and section BD.
So why we no need to cut the DE?
Why we no need to cut the DE? Because we have enough boundary condition to determine the section for portion BD by considering 2 sections. Basically, by section method, we only need to consider 2 sections. No need to consider until 3 sections. Usually lah, question for you to solve, right? If for complex question, we will set it as, we will use the singularity function method.
Okay.
But we won't ask you to use the bisection method. Okay, so consider 3 sections or 4 sections, and that one we will really it's really time consuming.
So for section AB, it says from 0 to x to L over 2, isn't it? Isn't it?
Yeah.
Be 0 x to A.
Huh? Pardon?
For section AB, isn't
Oh,
it?
sorry. Oh, from A. Sorry, this one is from A. Okay, sorry. Okay, so my bad. Okay, yeah. Question.
So is it possible to have 2 common points?
I mean, possible to have 2 common points. You considering if unless the question require to cut 3 sections.
Oh, okay.
If cut 2 sections, no need, right? One
Okay,
common point
understood.
is, yeah. Okay. Questions before I move to the next one. I think there are any questions. Okay, you can type if you don't want shy to voice out, then you can type in the chat room.
There is one question on 12 from Dian. Dian asks to explain question number 12.
Oh, okay, like come.
Okay.
Okay, so actually 12 I already prepared because I received an email regarding to this question. So yeah, I think I explained here. Right, okay, so I think most of you if you go through question number 2, right? So you if you refer to the solution, so the solution here do have this equation, right? X minus A. Okay, x minus A power of 0. Okay, so why we will have this x minus A equal to 0? Because if you look at here, this diagram, right? Okay, so the moment is at point D. Okay, so the moment is at point D, right? So if we cut a section in between BD, okay, in between BD from 0, from A, sorry, BD from A to L. Okay, so if we consider section BD from A to L, right? So, and this is the free body diagram. Okay, free body diagram, right? So, and this is the from A to the point that you cut is considered as X, right? And then AD is A, and then from D to the point that you cut is X minus A, right? Okay, so if we are using this, basically is a moment it will generate moment, right? So it will be moment multiplied with the force multiplied with distance. But for the moment, basically we just write down moment, okay? Because the distance is for the moment, right, is power of 0. Okay, so if we power 0 is power 0, it should be 1, right? Okay, but if we using this moment equation, right, after that, if we do perform the integration for example, okay, so perform the integrations, okay, so we know, okay, so perform the integration, right? Okay, yeah, I don't put the integration. Okay, so I just write down. If we perform the integration, so it will be, okay, so Okay, so it will be xy minus 2. Then this one will be x power x square, right? Okay, so x square. Okay, so and then minus, okay, the moment equation, m naught will become 1. Okay, so that's why we cannot just write down moment. Okay, 1 and then plus c1. Okay, so for example c1. Okay, let's say. Okay, so this is the when you perform the integrations. So the moment will be this equation rather than this, right? So therefore, if the location of the moment is located somewhere in between the beam, not at the end, not at the origin. So when you derive the second section, so you need to consider this, right? Based on this free body diagram, when you derive the moment equations, you need to write down in this form. It's required. Okay, why we need to write down in this form, or else how do we identify the location? How do we identify which moment? Okay, because the location of the moment that we subject do influence the deflection value. Okay, which means the moment at the end and the moment at the point D and the moment at this point. Okay, so this point will be will give a different, okay, value for the deflection when we calculate the deflection value. So it will give a different value, okay, based on the moment locations, right? So if we ignore this x minus a, so which means if I put my moment at this point, you will get the same value, okay, for your deflection. Okay, so this which means you will get the wrong answer basically, right? So it will calculate. So even though we know that for the moment at different location will give the different value for the deflection value. Okay, okay. So please do keep in mind that if due to this moment equation, right? So when you cut a section, right? So you need to include this, okay, the distance x minus a power of 0. Just leave it in this form, right? For the moment equation. After that, you just perform the integration normally, okay, based on this moment equation. Questions? Is it too fast or? Okay, so if you are shy, you just type in the chat room. Okay, so or you just, if you have any questions, you just ask. Okay, please do ask. It's very hard. Is it hard to digest this for this question for the moment? So I just because why I draw here. Okay, so why I draw indicate here. So if you use your own method, right? If you didn't include the x minus a power of 0, so basically this moment equation that you will get, right, for the location at point D and location at the new point, so it will be the same. Okay, so it don't have any differentiation. So when I subjected the moment at different point, even though it do difference, okay, actually is difference. Okay, it do affect the deflection value.
Okay, there's one
okay.
question in the chat. Yeah. Yeah.
Okay, so as I said, life is not easy, right? So for the test or the online test or the online assessment, for example, the assignment, so you'll be tested with a bisection method and singularity function method, both. Okay, both you need to know. Okay, so yeah, questions. Feel free to ask. Okay, both you need to know bisection method and the singularity function method. Okay, so no worry about bisection. Bisection, I won't ask you to cut until 3 to 4 section. Maximum is 2 section. Okay. Any question regarding to the singularity function or bisection method?
No.
No. Singularity function method, is it okay? Any question regarding to singularity function method? No, right? So however, you need to try all the question. Okay, so basically those question, right? So you are able to use the singularity function method or bisection method to solve. Just that the equation might not be the answer. For example, the equation of the elastic curve that you generate might not be the same. Okay, however, if you are using the equation to calculate the deflection value, it will give you the same value. Okay, so as I already sent you, right? So I think I did send you one example, right, regarding to I using 3 of the method, isn't it? Okay, so if I using bisection method and the singularity function method to solve the same problem, isn't it? Okay.
Yes.
Yeah, so basically you won't get the same equation of the elastic curve. However, if you are using the equation to calculate the deflection value and the slope value, you will get definitely you will get the same value.
Okay.
Okay, so yeah, so this is about deflection value, and then next thing I wanted to show you, okay, so I think I go to I think the last thing I need to show you, is the okay. Okay, so for those who just join after I discuss this. So we have one online assignment that you need to do, right, for this online assignment, right? Okay, so assignment 1, right? So there's 5 questions, so you need to attempt all questions, and then the marks is 10 marks for the assignment 1. So you just go to Canvas and then click on the assignment. Okay, so assignment under assignment 1, not assignment, assignment 1. Okay, assignment no more. Right, assignment 1. Right, assignment 1. Okay, so it's 10 marks. Right, so the download link is here, so you can download it. Right, so okay, so you need to attempt all questions and then show your full solutions. And then the due date is on 17 April. Okay. Okay, so submit through Canvas, and then how to submit? Okay, so just upload the file in either PDF or document file, words file. Okay, so for this assignment, you don't need to type. Okay, I won't ask you to type the equation, type the solution, or things, right? So all you need to do, just take out the paper and then try to solve it in handwritten. Okay, so after that, use the scan software. Okay, I think most of you have a scan software, right? Okay, and then take a picture and then convert it into PDF format and then submit through the Canvas before 17th of April. So if you have any questions, right, so you just drop me or Tiong an email. Okay, so and ask, please do ask. Okay, so we try to assist you, but you need to ask. Okay, so that we can assist you, right? Any questions regarding to the assignment?
No.
No, right. Okay, so from time to time, right? So because for the lecture, okay, lecture video. So basically, I already starting to prepare the lecture video. I think some of you already view this video. It's not, yeah. I'm trying to improve the way to present explain the slide, right? So it might take some time because this is my first attempt. Quite weird when speaking alone in front of the computer, so it's quite weird. It's different from the way to teach face to face, right? Okay, so you just go to the weekly 5. Okay, so basically you can I start to create a video from the column buckling. So next week I will try to upload the video for the torsion, right? Torsion video. So inside there's a explanation on how to some is on the derivation and some is on how to solve the problem, right? So how to determine the support pin fix the conditions, right, and so on. So if you have any doubts, just drop me an email. Okay, so for explanation. So yeah, so if you want to meet up on the Microsoft team, you just let me know. So yeah, I am fine. It's fine for me to meet you up personally. No worries. Right, just drop me an email and then make an appointment. Okay, either me or Mr. Tiong. Okay, so both will do. Okay, so this is about the online learning, okay, assessment all the things, right? So I think there will be a little bit change for the assessment in this semester. I think that the exam, so we won't have any exam for this semester, which means it's quite easy for you guys to pass, basically, compared to face-to-face teaching. Yeah, and so the assessment and the marks for all the assessment will be announced soon. Okay, so once we finalize with the counterpart, Melbourne side. Okay, so this is about the assessment that we have in this semester. So any question regarding to this few chapter? Any questions?
No.
No question, right? Okay, so please do try all the questions, all the tutorial questions, and then go through the slides. So if you have any difficulty, if you have any doubt, please do drop me or either me or Tiong an email, right? So we will try to assist you. Okay, so I think yeah, it's 4:37 already now, so I think I will stop here. So thank you.
Sorry for the
Yeah.
question.
Yeah. Hey, question. Yeah. Question.
For this session has been recorded, isn't it?
Yeah, this session.
I
Yeah.
can't really find that inside the Microsoft Teams.
Yeah, this session is recorded. I think I will upload it later on. I think
Yeah,
so.
but I believe that we can get it actually from inside Microsoft Teams without you
Yeah,
uploading it.
until we end the conversation, I think so.
Okay. Do you know actually where is it? Where can I find it after that?
I think it's under it's under the software, right?
The software.
Under the Microsoft Teams software. So once we end the session, I think we are able.
Okay.
I will send you the link. No worries. I will upload the video later on.
Thank you so much.
Okay, no worries. Okay. So questions. So yes, I will upload the video on Canvas. No worries. So you can access the video anytime. Okay. So okay. So I think okay. So and then there is a announcement regarding to the okay, one more things, the most important part, right? So please fill out this Google form and let me know your available time, right? So that I can try to have a discussion every week, at least an hour discussion every week to discuss the tutorial questions or relate. Okay, so some regarding to the lecture slide. Okay. Okay, so just fill it up, right? Okay.
Chua, please, if you can turn off your mic so we can hear Mr. Charlie.
Okay, so you need to fill out the this form. Okay, so yep. Any questions? Yeah, that's okay. So I repeat again. This for this session will be recorded. Okay, actually it's recorded. I will upload later on. Okay, so once the conversion is finished. Okay, so if there is no question, I think that's all. Okay, so thank you for joining this discussion sessions. Hopefully we will have a better improvement on the next one. Okay, so yeah, please if you have any feedback or any comment, like how maybe any requests, okay, so during especially during the discussion session, so please do let me know. Okay. Okay, so thank you very much. Okay.
Right, thank you so much, sir.
Okay.
Sorry for asking a lot of questions.
No worries. Okay.
Thank you so much.
Okay, thank you.
这样多写 thank you 还是加了？培养我的 MOS 老师。